Of Bauer Power, located in Wayland, Michigan. He started his career in construction. Is that right? Construction, residential construction primarily. Moved from that about the year 2000 into really with a focus on renewable energy, and he doesn't just focus on photovoltaics. He also does domestic solar hot water systems and turbines, right? Wind turbines. So any of these are possible from him. Mark is coming just this past Saturday from a large Go Solar event sponsored by GLREA at the Kentwood Library, correct? And he'll probably mention that tonight. He's been speaking, he's had many, many speaking engagements recently. He's a sponsor and a speaker at GLREA's, that's the Great Lake Renewable Energy Association. If you're not familiar with it and you're here, that would be your homework, would be to look at glrea.org by tomorrow night, because this is the resource, this is the source for you. He's a sponsor of the Michigan Energy Fair, which is held north of Manistee this summer in June. Onekama.
Right.
One comma, thank you so much, right? So, thanks, Mark.
Thank you, sir. All right. Let's see if we can get all this geek stuff going here. All right. I'm a solar guy, not a computer geek, so you guys are going to have to bear with me tonight. All right. I think we're set. So, electricity from the sun. First of all, thank you all for coming. Thank you for your interest. Renewable energy is in the news. We're hearing a lot about it lately. And it all started from the sun. In fact, our very existence, the whole planet, all of our energy comes from the sun. The most powerful source of energy that we know. So tonight, our agenda, well, I'm probably not going kayaking tonight, am I? I wish I was. Anyway, we'll talk about PV. We're going to look at examples of projects, and we'll do a Q&A period. Hopefully by the end of tonight, some of these questions may be asked, or answered, I should say, and asked by you already or wondering. And we'll probably go over a lot more, too. But those are just some of the topics that we'll cover tonight. So, what is PV? Everybody wants to know. Photovoltaics. All right, let's see if we can get this high-tech stuff to work.
This energy reaches the Earth to meet the world's energy demand for a whole year. Photovoltaic panels consist of many solar cells. These are made of materials like silicon, one of the most common elements on Earth. The individual cell is designed with a positive and a negative layer to create an electric field, just like in a battery. As photons are absorbed in the cell, their energy causes electrons to become free. The electrons move toward the bottom of the cell and exit through the connecting wire. This flow of electrons is what we call electricity. By combining solar cells and photovoltaic panels, we can produce just the right amount of electricity to perform a specific job, no matter how large or small.
Solar shingles, you're hearing a lot about those in the news. That's a PV laminate made right here in Michigan. Okay, it actually worked. Wow. Last session I did the other day, it didn't work. So, photons, when measured, act like particle wavelengths. Ultraviolet waves are stronger than infrared. We're going to talk a little bit about some of these things technically so you can understand the performance variations that silicon exhibits based on the spectrum of light that hits it. Okay? So just follow along here. For those of you who already understand this, I beg your patience. The solar spectrum is electromagnetic radiation made up of a range of wavelengths. Ultraviolet, 9%, visible, about 47%, and then the infrared spectrum, about 44%. The spectrum of solar photons that reach the Earth covers that wide range of 300 to 2,000. Okay? That's the spectrum we're interested in. Wavelengths visible by common solar cells range from 350 nanometers to 950. Okay, so that's the target range where we want to be in the spectrum of light. Okay, so let's talk a little bit more about seasonal shifts, and you're going to learn more about what the red and the blue means here in a minute, but just bear with me. So solar spectrum shifts. In the summertime, we're more towards the blue, in the winter, more towards the red side of the spectrum. Okay, just remember that. Also remember that when we get a cloudy or overcast, hazy day, we migrate towards the blue. Okay? Okay, so why is this important? So let's talk about this product that's made right here, or it is a product, thin film, that's made all over the world, but one of it is made right here in Unisolar, that's headquartered in Arbor Hills. They are extending their factory to Greenville. This is a thin film production. There's only about 50 people that need to work in this facility. It's about a football field long, and substrates and metals go in one end and thin film PV comes out the other. It's not very labor intensive. It will not give Greenville an economic boost in their labor, other than a very small amount of people. Matter of fact, Unisolar has more engineers on staff than almost any other company in the country. Very high-level engineers there. But having said that, amorphous silicon is a very practical product. It's malleable. It likes the blue spectrum of light. It's okay with hot temperatures. It's been around only a short amount of time. It also degrades a little bit when you first open it up and when you first break it out of the box and let it start seeing the sun. There's a lot of applications you see with the solar cells. The military uses it a lot to charge their batteries out in the Iraqi desert. You need a lot more of it. One of the drawbacks you see with this panel here, it's about the size of a common day panel, about 3 by 5, but that is only a 64 watt output panel. The same size panel made of poly or monocrystalline will put out 3 times that much. So one of the drawbacks to the amorphous product, thin film, is that you will need to put more of them on your roof, wall, or house, or business. A drawback in the sense that there's more mounting hardware and there's more labor time. They also make the laminate material that you hear a lot about, the stick down. So let's talk about another popular one, polycrystalline. Now polycrystalline is really kind of neat in the sense that it likes cool weather, medium history, been around for a while, very durable. It's not affected by partial shading and multiple edges to allow for better cooling. These are the 2 most important things of polycrystalline, their characteristics. If you have a string of panels, and these panels are all connected together, and by being connected together, they've built up enough power for you to utilize in your home or a battery bank. If a branch or a tree shades one of those monocrystalline panels, the whole panel is knocked out. With polycrystalline, if you know you're going to have some shading late in the afternoon or early in the morning, your home isn't quite always shade-free, you would not want to put a monocrystalline panel until it was completely free of sunshine for it to produce. So the polycrystalline produces in shade conditions. It's probably what I believe one of the more all-around better types of silicon. But having said that, monocrystalline is the one that's been around forever. Monocrystalline is the one you see on all of the highway signs. The old Siemens panels that the Department of Transportation, our government, bought years ago, they bought thousands of these panels. They're all over the place. Very popular, very good, very efficient. But a drawback, the center of the cell stays very hot and the edge gets cool. Where the polycrystalline panel, it is cool in many areas because there's more edges to the silicon. Okay, so it's just one drawback of monocrystalline. But if you're in bright, open sunshine, there's not an issue of any shading ever going to be on your panels. This is the panel of choice. Monocrystalline. You can always tell monocrystalline too, they've got this wafer-type shape. Anybody notice that polycrystalline, you can see the crystalline nature of it. Very easy to identify when you see the panels. Okay, CDTE. Where does everybody think the most expensive solar panels are? Of course they're in space and our government bought them. NASA has a lot of money, don't they? And they use this cadmium telluride stuff that's very, very powerful. It has a long history. It's very efficient. It's the most stable, and it's extremely expensive. But it's also the harshest conditions known to man, and the PV works flawlessly. The efficiencies are over 50% in space with these panels. All of our satellites, all of our substations, everything, all your TV shows that you watch, it all comes from energy that were made with solar panels on the satellites in our space station. Solar power powers everything we put in space. That type of PV is unavailable here, although it's coming. You're going to see some new technology out that just came out the other day about it. So modules basically are then the stringing of all of these small wafers together. One wafer may put out about 3 to 5 volts DC, but we string them all together, and this is a 20-watt panel. So we put them together in a series, and maybe several series parallel of each other. And the modules can come in various different sizes and different amount of wattages. Currently in the US, we can only get a 200-watt UL-listed panel. Although in Europe, they sell 300-watt panels. They're not UL listed here in America, and I would be violating the National Electric Code if I put them in. So I can't, unless you're off-grid, and no one's going to see it. Oh, no, I didn't say that. But anyway, 300-watt panels are really only available in Europe under the UL listing. Voltage ratings, DC, and amps. Now, this is an interesting thing. A lot of people call us and they say, you know, Mark, I want to go off-grid, and I want to run my air conditioner, my dryer, and my range, and oh, I do some welding, too. You don't have a problem with that, do you? Well, we can't push 50 and 100 amps through our inverters with photovoltaics or wind or any renewable energy. So what you can do is power almost everything else in your house. But that kind of amperage is why renewable energy will never be a base load. You hear a lot about this talk, and we're going to talk more about that too. All right, so what's the latest news? I can't get it any later than this, you guys. It just came out the other day. Georgia Tech Research Institute announced a new thin film process using cadmium telluride. And what they're basically doing, you can read it there, is it's a high-level process, but what it sounds to me like is the sun is going to be able to hit these cells in multiple sides, a 3D type effect. It's also going to transfer the energy better, the electrons are going to share better, and they claim that this will be far, far more efficient. Now, having said that, if you really want to keep up with the latest, go to these guys right here, nrel.gov. NREL, the National Renewable Energy Lab, continues to test these new breakthroughs that come out, and then they really give us the skinny on them. Thank God for NREL. There's just a lot of people out there with a lot of money that are inventing the new PV cell. And until NREL tests it, until the scientists really tear it apart, we really know what it's going to do. Good sources of information right there. NREL and renewableenergyaccess.com. Anybody heard of this? Anybody heard of it? Good. Well, good. Glad I was the first to bring it to you. So who makes it and who's buying PV? All right, there's a lot of stuff here, and I'm going to try to go over this kind of slow, but Sharp has been the leader for many, 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 many years. I personally buy a lot of Sharp panels. They're made in Memphis, Tennessee, but they are the world's leader producer of the actual wafers. They make the wafers in Japan. They ship them to America here. In fact, they ship them all over the world. They ship them to Europe. Europe is the current largest consumer market of photovoltaics in the world. Europeans are buying PV as fast as we can ship it. Unisolar is back-ordered 9 months to Germany with PVL laminate. Excuse me? Sharp sells the full-size panel monocrystalline and polycrystalline. They aren't in the thin film business. Good question. You can read some other things there about the production. I cannot say this name. Does anybody know how to say that name? Okay. That's where the cells are made. Then they're shipping them all over the place. They come to Memphis, Tennessee. Americans are putting them together in Memphis, Tennessee. I buy the panels from there quite often. I wait about 30 to 60 days to get them. Germany has less solar insolation than Michigan. This is an important thing. I want you to remember this, please. Current U.S. manufacturers' lead time is about 30 to 60 days. And Unisolars are backordered 9 months to the European market. 50% growth between 2004 and 2005. Now, a lot of it that has to do with the adoption of renewable portfolio standards, the deregulation of the power grid. Europe, Asia is far more conducive for renewable energy, and you can see it in their gross volume of sales. Japan has over 1 gigawatt capacity, of which 277 was installed in just 1 year, and that was 36% higher than the year before. By the way, Japan requires you put a 2K PV system on every new home built. Required by the government. Here we are in the United States. Oh, Germany, 366 megawatts online, a 150% increase. And here we are in the United States. We've put in a little measly 84 megawatts. But we've seen a steady 25% growth in this industry. Steady, 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 steady. This is important for those of you considering or thinking about the renewable energy business. Does Michigan have enough solar energy? All right, NREL, once again, NREL has a map for every month of the nation. Be careful of what it says right here when you go look at the maps, because there are maps that they have for dual axis tracking for fixed locations. What this map is telling us is the insolation we receive every day. By the way, we get about 20% less than Jacksonville, Florida, sunshine. A lot of people think we don't get any sun here. We get quite a bit. Insolation is the per meter squared measurement on a daily basis of the amount of sun energy that hits a given spot of the earth. So, when we look at Michigan, I use 3.5 as a factor. My conservative nature, I want to be on the little underside, and when you make more power than what I told you, you're going to be really happy. But having said that, a lot of people use 4 as the number here for Michigan. The whole eastern United States is the same. This is the summer. We're all averaging 5-6 hours of insolation in the summer per day. In the winter in Michigan, 2, and we average out, according to the data that I've been collecting for several years from customer systems that I collect their output data, 3.5 hours. So how does that factor into figuring out for photovoltaics? It's really simple. And by the way, when you go to the NREL map, make sure you look. Flat plate, south-facing, latitude tilt. That means it's at the same latitude of where it is. But here's basically how you figure out how many kilowatt hours that a photovoltaic array will make for you. Simply take the size of the array, multiply it by the time, the hours of insolation, and you'll have your kilowatt hours that your system should make on an average monthly basis. I don't care where you live. If you live in the southern desert of Arizona or California, or you live in Alaska, you can simply take your insulation number, multiply it times the size array you want to put on your home, and you'll know how many kilowatts you're going to make to offset how many you're using. And we're going to talk about that too. Does everybody understand that? It's important you understand insulation, where we are in Michigan, and how you figure out if I put up a 10K array, how much power would that make, right? Everybody understand?
How do you deal with that shade issue?
How do we deal with the shade issue? Okay, good question. I'm going to address it in a little bit, actually. Good question. Anybody else? Yes, sir.
So 3.5 is kind of the average number of hours per day?
Daily insolation of sunshine here in Michigan, right. And we get 6 in the summer, 2 in the winter. We average out to 3.5. So if you were to put in your own photovoltaic system, you ordered your own set of panels, and you got 1,000 watts of panels, what does that mean you're going to make per day? 3.5 kilowatts. What does that mean you're going to make per month? About 100 kilowatts. Following me? Everybody following me? Okay.
Does that change if you track?
Gosh, you guys are just full of good questions tonight. Yes, and yes, I'm going to answer more about that in a little bit. What are the basic requirements? Okay. As you can see, both of these people have tremendous, you don't know where the sun is, and I took the pictures, but the sun is facing this south wall side of this man's house. The sun is facing this whole man's garage here. People call us all the time and they want solar. God bless them, and they're in the middle of the trees. I can't help you if you're in the middle of the trees. So one of the most important things is that we have access 180 degrees due south. We need to see the sun. We prefer to see it within 5 degrees of 180 degrees south, but it's not a big deal if you're a little off of that. Okay? 35 to 55 degree tilt. In Michigan, what you typically do is take the latitude, 40, 42 degrees, and you want to be within 5 degrees of the latitude. And that's everywhere. If you go down to the tropics and you're at 10 degrees north latitude, your panels are going to be flat. But here in Michigan, we want to tilt similar to our latitude within 5 degrees. That's for hot water and for PV. Shading needs to be at a minimum. Anything over 30%, you may want to get out the chainsaw. Okay? It's really important that these panels get sunshine. Really important. Or don't put them up. Now, how are we going to deal with that? Good question. Solar Pathfinder. Okay, I'm passing around a little flyer. On the front of it's the actual picture of the Solar Pathfinder, and you're going to see the reflection of trees and actually some people standing there. On the back side is the trace report to show this person what loss of shading will create for their system. If the solar guy doesn't have this $300 little kit with him, get another solar guy. Okay, but you should have a solar analysis done on your solar window whenever you have your property looked at. Yes, it's solarpathfinder.com. Solarpathfinder.com. And they sell that device for about $300. Even a guy like me can figure out how to use it. So I'm sure you guys could too. And for $100, they sell you a little computer program that will spit out that nice little port. So it's really a $400 investment. Okay, now we talked about putting panels to the south. We talked about their degree of latitude. And just to go over, fully south is how many degrees? 180. And what's the optimum angle we'd like to be here in Michigan within 4 or 5 degrees of? 40, 42, right? Okay, so if you thought of a set of panels somewhere on a building, they would be at an angle that's conducive to 40 degrees, and they would be facing 180 degrees south. Okay, let's look at this beautiful building here. We're not going to talk about where it is because that's really not the issue. The issue I'm trying to make is that solar photovoltaics get put in wrong all the time. All the time. And in fact, this building has a 30,000 watt system on it. The problem is the laminate is laid horizontally on this building. Now, what do we know that insulation needs? What do we know that panels need as far as angle to get good sun? They need to be at 40 degrees, 30 at least. Horizontal, they're never going to see the sun in Michigan, are they?
Can you put that 42 degrees in something
1212 is 45, sir. So a 1212 pitch roof. Yes, a 1012, 1212. An 812 is bare minimal. You'll hold a lot of snow on your panels. But if you're building a new home, and if you have the ability to tell the architect, like Eric right here, a green-built architect, I will tell Eric every time he calls me, he says, Mark, what's that pitch got to be? 10, 12, 12, 12. Okay? That's important. So these panels are on this building. The 30,000 watt panels, the person who manages this building is upset because his PV doesn't work. I wonder why. Okay? It's imperative that the PV be put on correctly. I can't emphasize it enough. I would have never done this installation. I would have refused the contract. Okay, because I knew what would have happened. They'd be upset at some point. Okay, so here you are. The power company from 150 miles away at a loss of 73% in transmission is trying to get power to your house, and they're trying, and they get it there. They only burn 400% more coal and gas than they need to. So they get it to your house, and it comes in, it goes through a meter, it goes to your sub-panel, and it gives your home lights and appliances and what have you. Well, let's pretend we now want to go grid tie. We want to make renewable energy, and we want to keep it simple. So we're going to do photovoltaics grid-tied, which means we're connected to the grid, we see the grid, we feed home power into our home through the inverter, and it goes into loads. And when the home's loads are met, and your 1,000 or 2,000 watt system is making more energy than your home needs, it goes right back out the meter and goes over to your neighbor's house where they're watching TV. The electrons follow the path of least resistance. It's like water pressure. Your neighbor turns the valve on to get water over there. The water at your house would run over to his house. So grid-tied systems are very simple. You simply got a couple of disconnects, an inverter, a couple other important things, lightning protection and surge protection. The grid is very dirty. The grid will send surges and fry your $2,000 inverter. If your renewable energy guy hasn't spent $30 on 2 surge arresters and a lightning protector, you should have gotten another solar guy. Okay, I see it all the time, these systems not protected. Question? Very, very important. It's very simple. It just produces energy. The cool thing here too, folks, is you're going to get 90% of what you make, and you're going to use it all in your home. Never forget the fact that our power companies lose 60 and 70% transmitting power to our homes. That alone should be a good logical reason for you to consider photovoltaics. The simple pragmaticness of getting all your power and using it is what all of you would do if you were in charge of making that energy and paying the bills, wouldn't you? You certainly wouldn't want to lose 3/4 of what you make, would you? That's just profoundly ludicrous. So, grid-tied battery backup. Okay, so we've got the grid. We want to make solar power. We also want to store it in batteries and feed it into our home. And if the batteries are low, we want a generator to come on. And we also want to push it back through the utility grid if we need to. Wow, that sounds cool, doesn't it? That is the Cadillac of renewable energy systems. And I went one click too fast. When you do grid tied and you do battery backup and it's interactive with the grid, that is the best way to go and the most expensive. Xantrex and Outback Power make the inverters to do this. You will need a battery bank, obviously, and you will be able to not only store power, but have power when the grid is off and push your extra power to the grid when it's on. It's the true multifaceted way of doing renewable energy. It is the most expensive way of doing renewable energy, too. But you could have a critical load panel dedicated to this battery bank, and let's say the power grid goes down, the inverter detects that, it shuts down, and it only supplies power to the critical load panel. So this 48-volt system that you see here gives this man 6 days of autonomy. What that means is I've sized this system correctly, where if there's no wind and there's no sun for 6 days, those batteries will still keep his home powered. He lives off-grid for $35,000. Question?
My question is about, can this happen in Michigan yet?
This system is in Manistee, Michigan.
I mean, he can send it back to the powers.
This system is in Manistee, Michigan, working today.
But he's not getting paid for the
No, he's not.
What? That's
No, we're going to get into interconnection and net metering and everything, and I've got 20 minutes, so I'm going to keep rolling here. But we're going to talk about connecting to the grid, okay? We're going to talk about it. Okay, so let's look at PV working in Michigan today. I'm also going to start passing around now a flyer, and so I didn't burn up trees in our environment. This is on the inverter, typical that we put in a 2,500 watt inverter. I'll pass that around for you to start looking at. This inverter comes with a 10-year warranty, by the way, and it has a wireless display you can keep in your home to see what your system's doing. I've also brought a flyer on the Sharp 208 panel, made in Memphis, Tennessee. It has a 25-year warranty. I'll pass that around. And then here's a simple wiring diagram for those geeks out here in the audience that want to really see all the nuts and bolts and details of a grid-tied PV system. This is the actual wiring diagram we use. Very simple. Okay, so let's look at PV working today in Michigan. We're going to look at systems that are working here in Michigan. These are systems I've put in. I'm going to give you how much power they put out. This is going to be a lot of fun. Everybody ready? Excited? All right. This is on Watson Street. This is a home that Grand Valley built last year. It's an energy efficient home with ICF walls. The whole intentions were to build a low income home in a street just off of Fulton in a rough neighborhood, and to show the community that you can have renewable energy in an energy efficient home and have low utility bills and a high quality of life. So it's a 2K system, 10 polycrystalline panels. They're 208 watt panels each. They're fixed at about a 40-degree angle. I think it's an 812 pitch roof. And the average monthly output of this array is 192 kilowatts every month. It also has, well, okay, we're going to get to that. I'm going to go over how many kilowatts a normal house uses. But keep in mind these numbers. I'm going to tell you how the size of the array, and I'm going to tell you the output. So if you're not writing anything else down, write 2K and the kilowatt output. You're going to see about 6 or 7 systems here, okay? All different sizes, all different types of installation, all PV. So they also got hot water. We put the inverter in the attic. The inverter can go inside or outside. It can go in the attic, in the garage, in the basement. I don't care where it goes. I just got to hang it somewhere. Very simple device. Simply transfers DC current to AC. There's the job finished. They had actually a couple bigger trees over here that I got them to cut down. These trees are actually behind the house. That 2K array does very well. The house was spec'd to have 4 people in it. There are now 8 relatives living in the house. So it's using a little more hot water and a little more electricity than what we estimated, but it still does very, very well. Okay, let's keep moving on. Yes, I'm going to go over that too. So let's go to Langlingsburg, just a little northeast of Lansing. It's a 3K system, 14 polycrystalline 208 panels. They are on an adjustable rack, and the average monthly output is 324 kilowatts. You can see the lady first got a hot water system. She got it put in about 10 years ago. That system still works flawlessly. I checked it when I was there. Unfortunately, the guy put it right where I wanted to put my PV. But anyway, we put the PV up and gave her an adjustable rack, and we stood the PV off. She was very concerned about snow shedding and what have you. She wanted her panels to work all winter, all the time, so we built the panels up and off and right at the edge of the roof, so they'll essentially shed the snow right down off the roof. You can see her inverter hanging right here. We started putting this system in at 9:30 in the morning on Saturday. At 2 o'clock on Sunday, we were having lasagna and red wine with the lady, and her meter was going backwards. It was pretty cool. Very good lasagna, too. I love it when people feed us. All right, let's head to Coloma, Michigan. This is a 1.8 grid tied with battery backup. It's 10 monocrystalline panels, or 180-watt panels. They're kicking out about 197 kilowatts a month. They are at a fixed location, meaning that they're flush mounted to the man's roof. This is his Outback power station. You can see he's got one inverter. We're going to put another one here, another one here, and another one here one day. These systems are modular. A lot of people want to ask us, can they grow into their system? Of course you can. Just have to plan ahead. You need to tell me first, too. All right, there's his combiner box. That's all his PV coming together and then heading down to the inverter. Here's the panels that we put on this house. A lot of people want to know how big they are. So I took this picture just so you guys would get a sense of how big they are. They're about 3 by 5. And what kind of crystalline is this? Mono. All right. You guys are really paying attention. Awesome. It's right there, too. I know. All right, so there are the panels going in. Once again, flush mounted, monocrystalline. The guy didn't have a tree for miles, so we definitely recommended monocrystalline. System works great. It backs up his home. Now, we designed this so we can put another 2K here, another 2K here, and another 2K here. And he's also going to keep adding inverters. So eventually he will have 8K. He has a geothermal heat pump. His electric bill went up about 500 kilowatts. He could have gotten by with maybe a 4K to feed his home. He really needs about a 6 or an 8K now with that geothermal. But guess what? He's not burning gas. He's using the natural temperature of the earth and renewable energy to power his heat pump. Brilliant. Let's let Mr. Stivel get his little face and be famous for a minute there. It's always a nice thing to see a smiling customer. All right, let's head off to, where are we going now? Rockford, 2K, 11 polycrystalline, adjustable, averaging 188 a month. This man is in severe shading. When you see this site, you'll be like, Mark, I can't believe you put it up. He purposely told me to put it up. He said then he's going to cut the trees back, and he wants to see the difference between the first year with the trees kind of encroaching on his array and then what the difference will be. I kind of think he's a little crazy, but he's retired, and the man's as nice as can be. He's got a lot of time on his hands. So there's his roof. First we had to get the snow off of it. We gave him PV and hot water. And it's all adjustable. His hot water's fixed, but you can see his PV is in its winter position right now at about 55 degrees. Very nice sharp angle. Sheds snow great, has a good azimuth relation to the sun. It's really where you want your panels to be. You'll get about 5 to 7% more performance if you play with them 3 times a year versus just leaving them fixed. Not a lot more, but a little bit more. Once again, Bob's retired. He's got nothing better to do but go up there 3 times a year and adjust his panels. In fact, he calls me when he's ready to do it. Mark, I'm going to go adjust my panels. All right, Bob. And you can see here's more of his setup. And you can see the trees. He's just literally in a hole, you guys. I told him, I said, Bob, I can't do it. It's not going to work. Mark, I really want it. And I said, well, Bob, what about the trees? Mark, I really want it. We're going to take care of the trees. Okay. So it's going to be interesting to see what happens. All right, let's head off to Kentwood. Here's a 3K grid-tied system, has 14 polycrystalline. There was some shading issues. This was also very unique. This man had one little tiny hip roof, and he said, Mark, put as much as you can up there. I run a computer business in my basement. I want to say that I'm powering my computer business with green energy. What can you do? Wow. Okay, a little challenging, sir. I mean, that is not a big hip roof, is it? But I got 3K up there. How did I do it? I staggered the panels. The first row is at 35, then they go to 45, then they go to 55 degrees. You can see there's no shading. This is a winter photograph from this panel, doesn't shade this panel, doesn't shade the one behind it. It's the only thing I could do to actually get that much up there, keep them from shading each other, and he had every other damn thing on that roof you could imagine. Golly. It's not one of the prettiest installs in the world, but anyway. And here it is in the winter, I think, and you can see the snow shedding ability. In fact, you can see a little bit of snow piled up right here, ready to come off of those panels. That's right on Clyde Park, right before 52nd Street. All right, where are we going now? Uh-oh, we're leaving Michigan. Shh, don't tell anybody. We're going to Missouri. 4K grid tied, 24 polycrystalline 175s. They're flush mounted. They're putting out about 432 kilowatts a month. Now, the national average for an American home power consumption is 500 to 850. Write that down. So when you go home tonight, exactly. Everybody, did you hear his question? He's wondering about the daily hours of insulation. It's about 4 down there. I would give it a good solid 4. You could maybe even stretch it and say 4.5, but it's really just about 4. Well, that was the summer map that you saw up earlier. That was July. And we get 6 in the summer here. In fact, I've got customers that get as much as 8 sometimes. But 4 is what this system seems to be tracking. Anyway, let's just look at it. I'm embarrassed about this insulation, first of all. Okay, here's an architect and a builder that weren't on the same page. Because guess what? We're looking at the south side of the house. That's ugly, isn't it? When I got there, I was like, wow, this isn't going to be fun. And they had 24 panels for me to put up. Where the hell am I going to put 24 panels? Well, we had a plan and we did it. But basically, the builder wanted solar. The architect didn't think he would really want it when it was all said and done, and he would cut it out. And so the architect just put all these dormers on the back south side of the house. Now, this is a LEED certified home. It was on the St. Louis Home Builders Tour a month ago. They flew in 60 home builders associations from all over the country to see these 4 LEED homes built in St. Louis, Missouri. One of them got solar put on it, the one I did. One. And this is what they saw. Now, this is what I don't want them to see. This is why I'm so upset about it. But this is not what you want builders to see. Buzz here is not going to be very encouraged when he sees these pictures on what this solar panels did to the back of this house. Now, thank God this is on the back of the house. But if this was my house, and you said to me that's what it was going to have to look like when it was said and done, I'm sorry.
How many square feet were the monster?
Yeah, that's not. They didn't go to the class on conservative home living when they. Yeah, they missed that class, didn't they? And this is the key, you guys. Renewable energy is not the magic pill. It's not going to solve our energy problems, and it is certainly not going to solve your problems if you're an inefficient energy pig. This is an energy pig of a house. There's no way this home is really going to, suck power like they're claiming. I'm embarrassed about that, but we did it. You get paid and you do what you get paid for. So, all right, where are we going now? Manistee, 1.3 grid-tied PV backup, polycrystalline, 170 watt on a tracker. Cool. Now look at that, you guys. That little 1.3, that's 1,300 watts, does 171 a month. That's almost what a 2K does. Now that should show you the advantages of a tracker. A tracker will increase performance 10 to 30%. Here's the pole going in, lots of concrete, lots of rebar, lots of work. Homeowners love to stand around and watch us. They usually stand there too with their hands, their arms crossed. What are these guys doing? Now, I use passive trackers. Passive trackers have no gears and no motors. There's a gas that's actually moving from one side to the other. This radiator that you see right here, when the tracker finishes in the western position at the end of the day, that radiator is hanging very low. In fact, it's hanging so low that the morning east sun hits it, it warms up the gas, sends it to the other side, and the whole tracker in 30 minutes in the morning turns over and wakes up to the morning sun. And then all day long, it just slow. In fact, you can't even detect it moving all day long, and it tracks the sun. Incredible. The coolest geek stuff we got is trackers. And it is cool, let me tell you. All right. So everybody's been writing numbers down. What kind of crystalline is that? Poly, right? You can tell the difference now, can't you? Cool. Glad we're picking up on this stuff. All right, one more. I know these are ponderous, but what I'm trying to show you here is the broad range of installations that are working in Michigan, the types of output, and that you can do all kinds of different things. Okay, this is in Kalamazoo. If you don't write this down and go check this out, shame on you. Fatspaniel.com. You can go look at over 100 PV installs around the country, 24 hours a day. You can see what they're doing, what they did last week, what they've put in last month. You can look at arrays from anywhere from Washington State to Florida. So if you go there, I want you to look through the list and look for Wistar, Woodward School of Technology and Research. A buddy of mine didn't have insurance, and he called me because I have liability insurance, and the school needed liability insurance to put the system in. And anyway, his company, Renewable Energy Solutions, hired my company to put this in. Now this is on the web 24 hours a day. You can go look at this site any day of the week that you want to see, when it's sunny, when it's rainy, when it's cloudy, and see what it's doing in Kalamazoo, Michigan. We had to pay $500 to get the damn stuff up to the roof, but there was no way we were going to get it up there any other way. And we put the system in. What kind of panels? Monocrystalline, right? Everybody can see the difference there. And it's a ballasted roof system, which means it's floating on the flat roof. We never, ever, ever penetrate flat roofs. Period. Do never penetrate a flat roof. You are just asking for trouble. We set our ballast rated at 130 mile an hour winds. The only winds recorded in Michigan of any significance have been upwards of the 90 mile an hour range. So with that small amount of concrete, that system is ballasted, hanging literally on the edge of that school roof, and it's been there now for several years and hasn't moved. And you can see the inverter was hanging right there on the back outside. The kids monitor it. This is a K through 6 school. They study it, they track it, they love it, they call us all the time. And one day it went down and they literally were panicking. Mark, our solar system's down. What are we going to do? Calm down. All they had done was somebody had disconnected the wire off the TCP network and it wasn't going up to the web. So the inverter and everything was still working. It just wasn't on the internet, so they thought it wasn't working. Fatspaniel.com, they make the box that can put any PV or wind system on the internet 24 hours a day. Very, very cool when you're somewhere else and you get on the internet and you see what your system's doing at home. All right, I think that's the last one. All right, CO2. This is the one everybody's hearing about, everybody's talking about. We've all seen the Al Gore movie. CO2, CO2, CO2. What does it really mean? Okay, let's just say that you're a modest power consumer. And let's just say when you go home tonight, you look at your power bill and it says you use 780 kilowatts a month. What does that mean? Well, that's about the average. The average is 500 to 850. So that's not so bad, right? You're in the average. You're thinking, hey, I'm good. I'm not a big polluter. All right, what does it really mean? Well, let's show you what our friendly coal-burning power plants are doing on your behalf. NOx, SOx, and CO2. NOx and SOx never disappear from the atmosphere. Scientists are actually more worried about these two than this one. They know what this one does, but they're not really sure what this one's going to do. These two are just building up in our atmosphere, and we don't know what the long-term effects are going to be of SOx and NOx. So let that just sit there in the back of your head. We already know what CO2 does, and it's detrimental beyond imagination. Let's give you an analogy. Let's say your 780 kilowatt bill comes to you from the coal-burning power plant. What does that mean? It means you got an extra car and a half in your driveway equivalent. Or that your family would only have to plant 2.2 acres of trees every year to offset that CO2. Now, folks, 150 million American homes, we don't have 2 acres every American home to plant. And here's the other thing that's not in this equation. Your gas furnace, your cars, your jet airplane trips, your lawnmower, and all the other things that emit CO2. This is just your electric bill. You, one American household. So you can see what the compounding effects of CO2 are. If you just look at your own electric bill, and please go home and look at it. And when you see that it's 1,000 to 2,000, I hope you're embarrassed. You should be. You should be. I use 200, and I do not have renewable energy in my home. I live in a tree-wooded lot in a downtown where I can't put anything in. My wife and I live in a 2,000 square foot old beast of a house, and we use 200 kilowatts a month. It can be done. You can lower your usage. Just got to want to do it. What incentives are available? Homeowners can get 30% off the cost of a PV system maxed out at $2,000. But businessmen, guess what? 30% with no limit. You put in a $30,000 system and you're a businessman, the government's giving you a $9,000 federal tax credit. What's not to like? There are no Michigan incentives, but this is a hell of a federal government incentive, folks. Don't let 30% if you own a business just go by. And the government extended this to 208, so you have another year to procrastinate, okay? But having said that, please do something or tell any businessman you know that 30% of the cost of a renewable energy system the government will pay for. That is a tax credit. That's not a deduction. That's literally money that that business owes the government less now. Pretty cool, huh?
Both systems, what are both systems?
You know what, ma'am? My editing job wasn't very good because this is reflection to hot water also.
Okay.
Solar hot water and solar PV both have a 30% federal tax credit, and I didn't edit very good there. You're like my wife, you pick up on all these grammatical things. I'm not that good at, so thank you. But anybody, solar hot water, 30% too. Same thing applies if you're a businessman. If you own a restaurant, a car wash, or a laundromat, and you're using 200 or 300 or 400 gallons of hot water a day, shame on you. Put in a solar hot water system and the government will pay for a third of it. Okay, let's talk about power, interconnection agreement, and net metering. How many people think it's easy to connect up to the power grid here in Michigan? Wow, everybody raised their hand. Okay, well, let's talk about it. There's no RPS right now in the state. An RPS mandates that the power companies get a percentage of their energy from renewable sources. There is a bill in committee right now, but guess what? There's no teeth behind it. It doesn't say where the renewable energy's got to come from. One of the biggest complaints I have is RPSs that say 10% of power from renewable energy sources, but they don't care where you get it from. So what are they going to do? They're going to buy RECs. And if you've heard of the Green Currents program that DTE just announced, that's what they're going to do. They're going to buy renewable energy credits from Washington and Oregon and all these other states that have wind farms, and they're going to send your money there. That does no good for Michigan. RECs is a 19-year-old solution they started in New York State. It is not the answer to our energy problems. The interconnection agreement application is $100. That's not so bad, right? Yeah. Then they're going to tell you, okay, you want to do net metering? We're going to have to put on a second meter. It's $477. And your renewable energy guy's got to put it on. Boy, I wasn't very happy. And then we're going to come out, we're going to charge $75 to do an engineering study. Now, all of the inverters we use are UL listed 1741. It's the only inverter that you can put onto the power grid, dictated by the National Electric Code. You cannot put any other kind of inverter on. So the power companies do not, even though you tell them it's a 1741 inverter when you fill out their application for $100, it's like they didn't read it. They still send the guys out and charge you to test the machine that has a big UL sticker on it that says UL 1741. And they know it's grid tied and grid interactive. They know it will shut down when the grid goes off. But they still charge you to come out and test it. By the time it's all said and done, you're going to spend probably over $800 just to simply connect your home up to the power grid. That does not seem very fair to me. So what can you do? Well, at the risk of... Well, let's just see. Watch for a little black thing right here.
And there it goes backwards.
What's right with this picture?
Solar doesn't work in Michigan. Going around again.
That house is emission-free right now.
Thank you, Mr. Sun.
So, if anybody ever tells you that power meters don't go backwards, tell them they're crazy, okay? They do. They go backwards very easily. Folks, it's the path of least resistance. In 20 states, they have one meter. They basically spin the meter backwards the other way, and you get a credit, true 1-to-1 ratio credit. Here in Michigan, they give you a wholesale rate of 3 to 4 cents. We're going to change it. They are going to wake up. I would recommend always that you connect to the utility grid. I'm not very happy about the price that they're going to give you, but let's say we do pass laws, and they do enact an RPS. then guess what? You're going to want to get that full retail rate for your power that you're overmaking, aren't you? Well, if you hadn't done it now, you'll be waiting a year or so for these knuckleheads to come and put your meter up. And that whole year, you wouldn't get that retail rate. So, as painful as it is for me to tell you to hook up to these guys and pay these kinds of outrageous fees, I would highly recommend it. It'll only take about 4 months. Absolutely ridiculous. They're mandated by the MPSC to do it within 30 days. I'm taking them to court over this. We have several customers who have been tracking this whole process, and we are going to change this. It's a big mountain, you guys. It's huge. How much does it cost? Who asked that earlier? Yay! All right, here we go. Everybody wants to know how much it costs. I'm going to tell you. Okay, wholesale current rate for PV panels. When I buy a panel, and I call up and I say, I want to buy 50 panels, 20 panels, I pay $4.50 a watt. So a 200-watt panel costs me in the neighborhood of $900. It retails for about $11.25. Okay? Then the next thing I'm going to do is I'm going to add an inverter and wiring, and I'm going to bring guys out, and we're going to hook it into your home. And by the time we get it all hooked up, it's at about $8 to $12 a watt, grid-tied, depending on what size of system you put in. If you put in a 1,000-watt system, it's usually $12 a watt. And if you came to the Go Solar program just the other day, you saw that I have that same system priced at $9,800 right now for a 1K PV system. $9,800. Less a $2,000 federal tax credit brings you down to $7,800. The more wattage you buy, the closer to $8 you're going to be. If you buy 3 to 4K worth, you'll be close to $8 a watt. Now, if you add batteries, and you want to go off-grid, and you want to have a 12, a 24, or a 48-volt system, and you say to me, Mark, I want 6 days of autonomy, that's going to affect the price per watt of about $12 to $16. Trackers add about $2,500 to the cost of a pole mount, and will add about 10 to 30% better performance. What we actually do in the winter, you guys, is fix them, though. I have found that leaving them track in the winter, a lot of times they'll just stay fixed in the west position because they just don't get a full nice day of sun. There was no sun in the morning to wake it up and to turn it over. So in the winter, typically on December 1st, I fix all of my trackers 180 degrees south at about 50 degrees. I come back on March 1st, I knock it back down to about 30, 35 degrees, and I let it start tracking again. If you really want to maximize your PV's potential, if you really want to get the most out of your photovoltaics, have it track the sun. Front end loaded, it's very expensive. You're buying all your energy today. You know, the power company loves you guys because you just make these nice little payments, and frankly, you know, it's always going to be going like that. The cost of energy is going to continue to go up. Ironically, your usage is going to continue to go up. You're going to use more over time. You're probably not going to get efficient. But let's just say you do. And let's just say you level off and you become a little more efficient. Well, what you're going to do today is you're going to buy some PV. And what you're really buying is power for the next 50 to 80 years. Photovoltaic cells will last 50 to 80 years. They're warranted for 25 years. The poor quality ones we made 40 years ago are still working. And the silicon, the quality, the purity was terrible. Now the panels that we're putting out, the pureness of the silicon is very high. The panels will go for 50 to 80 years. So you buy, say, 100 kilowatts of power today. You put up a 1K system. That's 100 kilowatts of power for the next 50 to 80 years you'll never, ever, ever buy. You front-end paid for it. You bought it at today's prices, and the cost of energy will go through the roof. The value of that 100 kilowatts will keep always going up, but you only paid what you paid in 2007 for it back then. You're buying your energy ahead of time versus making little payments and flushing them down the toilet. If you buy your system ahead of time, you own your system. It's an asset to your house. It will add value to your home. Your home will sell faster in the market. I guarantee it. When RE/MAX starts querying homes with solar and wind, you can go to RE/MAX now and query it for solar and wind. Guess what? All the homes without solar aren't going to be seen. Homeowners are looking for homes that have renewable energy in the future. It will be money comes back to you down the road. I hear a lot of terms, a lot of people say, what's the payback? You know, the payback is you're making clean, free energy. The payback is that we're not leaving a legacy years and generations down the road. But if you're concerned, and if you do want to haul that U-Haul behind your hearse and you want to save as much money as you can, buy the energy today and keep it from affecting the cost of energy. It will continue to rise, and it has never gone down. It's front-end thinking. It's kind of like buying your home. You got that 30-year mortgage, but once it's paid off, you got this beautiful shelter. Well, same thing with photovoltaics. It's really hard to buy 200 or 300 kilowatts of power now today. But guess what? You're going to use that 200 or 300 kilowatts forever. You're not going to not use electricity. Is PV the answer? Well, they're putting up huge arrays all over the country. In fact, they're putting one up in Canada, aren't they? 40 megawatts. Power companies all over our country are starting to wake up. It's survived the harshest known conditions to man. It is non-mechanical. It's the only form of electricity that is non-mechanical, no moving parts. That means it has no maintenance. It has no consumables. You never need to feed it anything. You know what the largest consumer of fresh water is in our world? Power plants. How much fresh water do we have in the world? Does anybody know? 97% is salt water and 3% is fresh. Of the 3% that's fresh, 1% is drinkable. Of the 1% that's drinkable, half of that we flush down our toilets. And power companies aren't doing us any favor. They use a tremendous amount of water, and they do not want you to know that. Has no byproducts. It makes the same energy it took to produce it in 3 years. A lot of people ask me this. Well, it took energy to make those PV panels. It sure did. And in 3 years, they've made the energy that offset what it took to make them. So now, for the next 47 years, they create net energy. There's not a power plant built that can say that, is there? 90% of the energy you generate, you'll use. No transmission loss. If there's no other logical reason to do it for that reason alone. I really compel you to think hard about the fact you'll use and get everything you make on your house. Silicon is the second most abundant element on Earth. The consumption today of energy is about 13 trillion watts. Okay, that's about what we use. Terawatts. Okay, what does that mean? The sun pumps 120,000 to the Earth every year. And we're not harnessing this energy. Amazing. So PV could probably help, couldn't it? The solar industry is a $7.5 billion industry. It grows in excess of 30% every year, but only accounts for 0.1% of the world's energy. Wow, what an opportunity. I think it might be the answer. I hope it is. All right. Who can tell me who said this quote? No. It was said in 1931. Does anybody have any ideas? Anybody at all? Just throw it out there.
Albert Einstein.
Close. Somebody thinks something related to Albert Einstein, kind of. Ah, bless your heart. Mr. Edison said it in 1931. You guys, thanks for coming tonight.
What was that? The sun terawatts was 120.
120,000 terawatts. Thank you very much for your attention. Questions and answers. Go ahead.
So are there ordinances? How do municipalities look at putting these things on?
Okay, good question. Typically, the wind machines and associations have a hard time with anything on the front of your house if you're in Heritage Hills or what have you. So you will need to have me maybe take a digital picture, superimpose the panels on there, and go to your homeowners association. If they tell you got to put it in the backyard, no problem. We'll work around that. Wind machines can be a problem, but usually PV and hot water is not a problem unless there's an association related to it. Good question, though. Go ahead, Sarah.
How much extra does a pole mount add to the installation cost?
The pole mount is really, the steel is about $400 or $500, like about $1,500 just to go pole,
Okay.
but about $2,500 to make it track.
25 plus the pole?
No. $2,500 is the pole and the tracker.
Oh, okay.
$1,500 just the pole.
Gotcha.
The prices of $8 to $12 a watt are roof-mounted grid-tied systems. It costs a little bit more to put it on a pole or to put it on a tracker. The cheapest installation is a roof mount. Good question. Go ahead.
What effect does snow have? With the tilt, does the snow fall
Good.
back off or melt off?
Good observation. Okay. Let's look at this panel, this tracker. It's at a severe tilt. If this was on a roof at 812, first of all, you couldn't get to it, and it wouldn't be at that extreme angle. So the beauty of pole mounts, whether it's a tracker or not, a pole mount that we sell can always be adjusted relative to the angle of the sun. It just won't track the sun. So if you get a pole mount, there's 3 advantages. 1, it'll be next to the ground, so you can get to it. 2, the snow reflection from the sun will add 1.2% of the sun's energy. It's really awesome. I've put a meter on and tested the sun's reflection from a pole mount like that, and it's 1.2% the value. It's incredible. So pole mounts near the ground get the sun reflection. You can shed the snow off them if you need to or if you want. It's a beautiful sunny winter day and you're saying, wow, I wish my panels would work today. Let's go out and brush the snow off of them. The sun's going to hit it anyway, and at an extreme angle, a little water will start running behind it and shed it right off. But having said that, if they're on your roof or someplace you can't get them, and they're not at a steep angle, they will hold some snow for a few days. The best thing to do in Michigan is to do a pole mount on the ground so you can adjust it during the year, and you know that in the winter, at that angle, it doesn't hold snow, you guys. When I put them at that 60-degree angle for the winter, they never hold any snow. If it's on it for a few hours. If that sun comes up at all, it's right off of it. Excellent question. I think you had a question.
I wanted to know if you've ever done an installation like for a whole day, or do you just do it when at a
Community generation. No, I have not. There's a community down in Kalamazoo on the way to White Pigeon. I'm working with somebody. They may want to do community generation, a large wind machine. It's going to be about 12 houses, and we're going to do a photovoltaic array. They're all going to do geothermal, so they're all going to have a tremendous amount of electric needs, right? Geothermal will add 300 to 500 kilowatts to your electric bill. Your gas bill will disappear, but damn, my electric bill went up. Well, you can make that 300 to 500 kilowatts that you've given yourself. And these communities are starting to arise. Architects are starting to hear about it. Eric's here in the audience. He's working with several communities, green communities that are being designed right now. And that's coming. Because why? We don't have transmission loss, do we? If we made power within a 5 or 10 acre community, all the power would be utilized. We'd size the wire right, and we wouldn't have transmission loss. Those guys should be shot, losing 60 and 70% of the energy they make over those lines. But it's the system that we put in place, guys. It's really not their fault, but they're kind of perpetuating it. Community generation, we all should do something on our homes. Go ahead.
How much extra is the cost of a hot water heat?
Okay, so we're going to step out of the PV question. We're going to jump into hot water. Hot water systems go in for about $5,000 to $7,000. And they also qualify for a 30% federal tax credit. If it's dedicated to gas in your home, it's a quarter or maybe a third of your gas bill. And if you have teenagers, it's maybe half of your gas bill is associated to making hot water. The Department of Energy recommends solar hot water. Over 2 million American homes have those systems in place right now. 94% of them are happy with them too. You can go to the... Sir?
How's it stored?
Usually there's a storage pre-warmed cylinder. What we do is we take that cold 50-degree water coming out of the well of the street, we heat it with the solar system and store it 90 to 140 degrees. We then feed it into your existing system pre-warmed. The BTU gain necessary that your existing system has to do is minimalized. You pre-warm all the water feeding that system. Making water go from 50 to 130 degrees isn't easy. Think about it when you guys boil hot water or boil water to make spaghetti. It's the only thing I do in the kitchen, and it takes me forever. I put the pan of water on. My wife wants to know when the noodles are done. I'm like, honey, I got the gas on. It takes a long time to heat up that silly little pot of water, doesn't it? Well, think about heating up 40 and 60 gallons every day for your family. How much gas that must take, or electric energy. Let the sun do it, you guys. In Michigan, a small, modest system, the Go Solar program system is $5,300 and includes 2 panels, an 80-gallon tank, and it will make 57% of a family of 4's hot water needs annually. Over half your hot water free from the sun.
Can you tack that out to an on-demand water system?
Oh, God, it could hug you and kiss you. All right. On demand. Absolutely. Okay? That's like one of the coolest things that these builders, Buzz here is in the audience from Standale Lumber right here in the front. On demand is the deal. Okay? Right now you've got this tank, and I'm going to come in and I'm going to put another tank next to it, and I'm going to pre-warm all this water 90 to 140. Then I'm going to send it over, and this thing is going to then send it out, right? All right. Well, let's eliminate this beast right here. Okay? And then let's call up Buzz, our local HVAC or plumber guy, and we're going to ask for the Bosch temperature-sensitive instant-on unit. And I'm talking the full house ones here. I'm not talking out the little tiny ones. And basically, because it's temperature-sensitive, it'll come out of the solar system. It'll go into the instant-on. The instant-on says, hey, it's already hot, and it sends it to your house. What have you eliminated doing? Needing this 40-gallon or 60 gallons of storage being heated by your gas or electric. You let the solar heat it, you let the solar store it, and then you feed it to the instant-on. The instant-on makes sure that it's hot and that you don't have a cold bath and your wife or family isn't upset, and on it goes. That's the way you want to do it for new construction. Good question. Thank you for asking it.
And the instant-on system is electric?
It can be electric or gas.
Okay. And can it take cold water in as well?
Yes.
For those days when you've got the panels on the roof that are snow-covered.
Okay, well, okay.
Get more water
Let's
in the
just
shower.
say that the 50-degree water's coming in, 50-degree water's coming in, and there's no solar activity. 50-degree water's going out. The instant-on boosts it to 130 degrees. But here's the cool thing about your solar reservoir. If I make that 80 gallons of water, and by the way, I can make it in one day in about 4 hours of sunlight. I can make 80 gallons of hot water. So let's say I make that 80 gallons because you're at work or you're at school and you come home and this big tank is all heated up. But let's say you don't take a shower, you don't wash your hands, you don't do anything. You're just stinky. Okay, you wake up the next morning, you lost 2 degrees out of your tank. So, you still got hot water. Now, take a shower, would you please? But this is the cool thing, okay? You make hot water during the day, you use it, you run your dishwasher on the little timer so it comes on at 12. You do your laundry if you can. Then the solar replenishes itself between 12 and 4. Then you come home at night, you got a whole storage tank of hot water for your teenagers and your family to use hot water during the night. It fills back up with 50-degree water. The next morning, it's 50 degrees. It's waiting for the sun to come out. The sun comes out, heats the tank all over again. By noon, it's hot again. These systems work flawlessly. I love hot water. I love PV. I love renewable energy. And I love you guys. Thanks for coming. Seriously. I'll pass my cards around. Thank you.